My name is Alex Berger. I'm a senior TME for the Meraki switching team. And I'm here to talk today about a solution that we have come out with a little while ago, but are trying to continuously iterate on, and that's Meraki's adaptive policy, which is our take on effectively Cisco's TrustSec solution, provisioned through dashboard. I think the one thing that I like to try to start off with, especially when describing this to customers or working through, and anytime I do any trainings, is why deviate from how we've always done security. And I think a lot of that has to do with the fact that when we started doing security in networks, and I've been doing security in networks for 14 years, I think, somewhere in there. We've always kind of started off something simple. And a lot of times customers' networks were like /16s. I've worked in hospitals and it's a nightmare. They have one VLAN that has all their servers in it and can't migrate anything out. And when they do, they end up splitting it out, and we end up, had kind of worked towards, security through VLANs, some semi-obscurity, and using access lists, and attaching those, for instance, at that layer 3 point in the network. And access lists are great until you need to deploy a lot of them and then maintain them. One of my favorite, I shouldn't say favorite, it was not, but a project I went on back before I came to Cisco, I got to do a 1,200 line ACL review with a customer and a firewall, and they did not know what most of them were for. And that's because over time, when people leave, it's really hard to maintain something that is so monolithic. And when it comes to ACLs, though, I guess the real point here is the fact that if you have a ton of sites, you have a ton of subnets, every time you make a change, it is exponential when it comes to how many changes you have to make, how you have to schedule them. A lot of times, when it comes to securing traffic, when you apply an ACL at the upstream layer 3 interface, you lose out on how do we control traffic in that same VLAN? Because in a lot of cases, you look at the best example of why security is important is IoT devices that are inherently, well, they don't do a lot well, at least. Hopefully they measure temperature, et cetera, well, but usually they don't do network security. They don't really get patched very easily. And so a device could get compromised and then start spreading crap all through the network. And so one of the key things we want to try to cover is how do we actually take care of intra-VLAN traffic, or if a customer has effectively a project towards getting to zero trust, how can we make sure that devices in the same VLAN can be controlled and in a manner that makes sense, so that, for instance, if I have a device that's someone brought in, they can't communicate with any of our corporate assets, for instance, but maybe have them in the same subnet. Maybe it's a small site and I don't really want to architect out 5 different VLANs for 5 devices. I've seen it, I've done it. It never works out as well as you want it to, but in the end, I think the problem statements that we're trying to solve effectively are, and these are these problem statements, I should more so say, are questions we got from customers over the years. Is how do I minimize exposure, when there is something that happens, right? And how do I make sure that if I can control endpoints in a kind of a clear, understood manner. In a lot of cases, that's multi-tenancy, right? When you have lots of different groups working together, potentially from different organizations or even contractors coming in and having to connect to the network, how do we make sure we can secure those endpoints? And then if something is compromised, isolate it easily. And then there's also this big one, and this is buzzwords, but how do we implement a zero trust framework? How do we get things in place so that we can actually implement zero trust? And in the long-term piece here is also, how do I maintain security audits, right? I mean, I think we've all probably had to comb through configurations, explain access lists to an auditor. And, well, sometimes those are the most difficult conversations to have because they take forever. But in the end, that's where we came up with adaptive policy, which is, as I said earlier, our take on micro-segmentation using security group tags over the data plane. The one key piece here is that we decided this would be best to live at the organizational level. So within dashboard, we have a hierarchy of networks where we put our devices, and that's where usually our very specific configurations live. And then we have the organization level configs, and that's where we, those are adopted by all those networks effectively. And so in this case, when we build the policy, and I'll show this here shortly, it is at the organization level. And in this case, we are using inline security group tags. We are absolutely encapsulating traffic with the CMD header. Our APs do it, I promise. I've had people ask me so many times, they're like, but your APs don't do it, right? And no, they do. We did write the software stack to make that functional. And not only that, but what that really gives us is the ability to share context between an access point and the switch, or an access point to another access point in another part of the network, and be able to provide micro-segmentation doing that. So instead of having to have, I mentioned this earlier, but out-of-band control plane connections that are resource intensive and a lot of times really fun to configure, we can just share that data over the data plane. Now to attach a tag to an endpoint, we have a number of different methods. Obviously, there's static assignment. We could do it to a switch port, an SSID. My favorite is using radius, just because of the fact that it is allowing us to add more conditions to why we attach an SGT to an endpoint. And then there's that kind of fallback last resort, which is effectively an IP prefixed SGT map. Not all customers have effectively trust set capable devices throughout their entire org and all their their services, and so being able to specify, an IP to SGT map means that I can take care of devices that live externally to that adaptive policy domain and still be able to attach policy as that traffic comes into the network. And as I mentioned, this is one policy configuration. So when you go to the organization level, that's where you define all of your policies, all your tags, all of your custom SG-ACLs. And so when you make a configuration change at the organization level, it does propagate down as a config update to all the nodes with the feature enabled. And so that means that if you had something horrible happen, like IoT devices were starting to do weird stuff, and you needed to make a policy change, you could do so in one place and have it actually go everywhere and not have to schedule config changes for each site, site by site. That being said as well, API first. I actually really have grown to appreciate API first in the fact that we built every aspect of this feature set to leverage our public APIs. So when you configure something in dashboard, there's an API endpoint to also configure that. So if you have a third-party tool that you'd like to integrate or create your own software, you can do so and not only configure, but also consume any of the information from a monitoring standpoint. So there's a couple key things to understand. We're not syncing policy based on the clients connecting to the switch. If you're familiar with TrustSec, typically what happens, and this is how TrustSec scales to alarming numbers of SGTs, is that when a client connects to a Catalyst switch, they will effectively, if they get an SGT, that switch will actually reach out to ICE, pull that policy down, and install it at that point. Given the fact that we wanted to run all of this as kind of through dashboard, we actually provision the entire policy set, all the tags, et cetera, in the devices already, so that if you connect devices, there is no delay waiting to communicate with the cloud, because that could take a little longer than anyone wants. And so in this case, we do have a maximum tag number of 60. When we were doing some research, we found that working with the ICE teams, we found that average customers use about 24 tags. Some of them use more. But in the end, I think 60 tags means that we can be fairly granular on our policy assignment, but not get so crazy as to create a tag for every person that exists in the organization, because that's just not going to work. But in that case, we also support 7 custom ACLs or SG-ACLs per binding. So if you have IoT device to IoT device, you could have 7 SG-ACLs with 16 ACE entries. So it does give us a fairly lengthy, effectively, policy that we can establish between 2 tags. And this last bullet point, I always like to bring up, since we're not doing SXP and since we're not trying to sync all of the clients in the network and what tag they have, and since we share it over the data plane, we don't have to worry about scale becoming a consideration when it comes to the security policy itself. The only scaling considerations in that case would be the platform itself and how much cam table, resources it has in general. So.
Question.
Yes.
Maybe several questions. So Drew Conway Murray from the Slack channel had asked, is this adaptive policy, is this Meraki only that you're presenting right now, or is that also a marketing term that applies to ICE-based DNA center, et cetera, et cetera?
In this case, this is what we coined it as in dashboard. So this is dashboard specific. Now, I will talk about this in a little bit. We built it this way for the sheer purpose of actually being able to interoperate across the board. Once again, if you're not familiar with SGTs, I know that there's folks probably watching that may not be familiar. It is an actual extra header encapsulation that carries the, for every packet a client generates, carries the actual SGT value. It is not actually a client source tag at all. So it is implemented from the network infrastructure. So if you were to do a packet capture and you did a packet capture on like the wireless interface of an AP, you would not see any tags. And that's a fun one to explain. I've had people ask me, well, then where do you capture? And it's usually right there. So usually in the link between the network appliance and upstream. The one key thing that I think we a lot of times overlook, especially when like I've seen plenty of like TrustSec presentations. Darren Miller does a really good job. If you haven't seen any of his breakouts, like describing how this works. And the one key thing here is that, and this is something that like I've had a lot of people say, it's just security. It's not just security though. It is actually really interesting in the fact that we're able to attach identity to every packet, and then as that packet makes it to a specific point in the network, do something with it. Today, we don't do anything extra per se with that other than security policy, but there is potential for, making next hop routing decisions, QoS decisions, all sorts of really fun stuff that you can do with that extra bit of context. And in this case, like if you think about it, using just the data plane, we can have a tag attached to traffic, have it go through the network, and for instance, have a firewall be able to say, oh my gosh, this is an employee device generating this traffic. Let's do an employee policy. I will talk a little bit more about this in a moment, and I do have this slide actually. I was going to hide it, and I think once again, you don't see tags here. You don't see tags between the server and switch, the client and the access point. It is in the infrastructure. Now when
you add the SGT in, because you said it increases headers, does that kind of use space that was already there, or does that affect MTUs? Do you have to tweak MTUs to make it work?
So one really cool thing about the Doppler ASICs that are in the 390, 9300, and our access points to this as well, is we actually, it's kind of a dynamically stretched. So when there's a CMD header, you don't have to adjust MTU, it does it for you. If you're familiar with like older, like if you run like not iOS XE, and you turn on TrustSec features, you did have to adjust the MTU size, but that's one nice thing, you don't have to.
But if you had hypothetically, two MS9 390s, and those were connecting through, some other core switch that wasn't Meraki, you'd have to increase the MTU there because you're adding that tagging to it though.
Right. Yeah, that's actually a good question. So if the device, so one thing you have to do when if you want to maintain tagging, you have to have TrustSec capable or CMD capable devices in that whole path to be able to maintain a tag from, source to destination. That being said, usually then in that case, like if you had like a 9500 in the core, it will, if you implement a couple like interface configurations, it'll dynamically adjust as well and ensure that the traffic is, or the MTU is adjusted and increased by, I'm gonna feel really bad just guessing, I think it's 16 bytes or whatever. So
okay, so there is some kind of outside of the Meraki world, you might need to make some config changes to get this to work just because of that header change.
Yes, yeah, and so when it comes to like switch support, there's actually some work being done on some non-Cisco ASICs to support inline tagging as well, and which is exciting, which kind of brings it well beyond just Cisco's purview. It's not and one thing I want to just real touch on is it's not like proprietary at all. Like we've put it out there, and there's an RFC for it and everything. So it is something I'm excited to see adopted, because today if you have an ASIC that is doing any level of inspection on traffic and it sees that CMD header, it has no idea what it is. And it looks like a malformed frame and usually can be dropped. So that's why it is important, like when you're designing, if you are propagating tags from a switchboard configuration, making sure that the next hop does actually support them. Because sometimes that doesn't work out well if you do that on accident. Is how we can couple the MS390 or 9300 in management mode as well with secure network analytics, which is also called StealthWatch still to me, and ICE, where we could have things like exporting flow telemetry and also including that SGT value means that StealthWatch can actually have rules built that, for instance, if I see an employee device and it's downloading a crap ton of stuff from my PCI server, I might want to change that device's policy, maybe change its tag, quarantine it. And it does that through pretty fun means of just NetFlow, and then it makes StealthWatch can trigger ICE to send a COA and change policy. It's really fun to actually mess with. That being said, this is my favorite thing for demo slides, and I'll probably keep this forever. All right, so as I mentioned earlier, this is at the organization level. And so you'll notice if I go to organization and adaptive policy, this is where I get to my actual list of the different groups I've defined. Adding a group is simple. You can just click add group. At this point, you can give it a name, give it an SGT value, description. We also have this policy object binding. And what this is if you create, there's another menu that we actually share with MX, and that is the policy objects, where you can create like IP groupings and then be able to apply them to like a firewall policy. We also have this type called adaptive policy group in or CIDR, and it actually you can specify either a host address or a subnet. And so if you needed to have like a fallback tag, let's say you have a server subnet and you want to make sure that like anything coming from that server subnet untagged gets a tag of X or Y, you'd do that here.
So you said that ties into the MX. If a policy exists, will that show up as a dropdown with everything that's on the MX, or do you have to like type a name exactly to get it to match?
So the policy objects bit is shared between the two. So if I go here, what I mean is this is the same UX. So there's like, you notice these say adaptive policy CIDR, and if I went into to build an MX like object, I'd actually create a network object. We had to make them separate just due to the way that they're provisioned under the hood. If a customer creates a bunch of groups and network objects, it becomes a really stringy mess of like stuff moving all the time. So
you're not associating one to the other. You're just kind of creating two different types, and
yes,
then it exists throughout.
And the idea here is to be able to have, in this case, a bunch of definitions of resources that I maybe need to attach to a specific SGT. There's two purposes. Obviously, if it's external to the domain and I can't get a tag attached as that traffic ingresses, I can do so when it comes into the domain by creating an IP to SGT map and using this. So once you define your groups, you can start building policies, but I want to go to custom ACLs first. These are SG ACLs, so you go in and you define source destination. They are IP agnostic. You can make them IPv4, v6, so if you really felt like it was necessary to match to a specific IP version, you can, but being agnostic means I can attach this and any traffic will be processed through that ACL. But once we create the actual custom ACLs and we go to the policies tab here, you can add policies, and we actually give you a UI to selecting like an employee device and then saying, I don't think employees should talk to guests, and click deny. And then if I go, so the nice thing here is like we can see a list of all of our policies we've defined, and you'll notice I have like this quarantine tag, and pretty much can't talk to anything in the network when it's assigned. But if we go to like this IoT device to IoT device, and I highlight here, I have a couple custom ACLs that I've defined, like MQTT and permitting ICMP and denying everything else. Or if I look at like this student to network services, I used to work in public sector quite a bit, and I like using student teachers as like examples for policy because they differ so much in what they're allowed to do. And students always like to do things that are terrible, like randomly trying to airplay stuff that they shouldn't to people's Apple TVs, you name it. But in this case, being able to list out and have a number of ACLs we attach permitting or denying specific traffic. Like for instance, if I was doing central web auth with ICE, I could permit like the specific ports for that, but deny like HTTP, HTTPS to ICE so they can't get to management and DNS, et cetera. So once all that's defined, the only thing we have to do to actually enable it is go to this networks tab and click enable. Oh God, I'm about to spill my water. And when I click enable, it was already enabled, but either way, what it does is it'll actually validate the firmware version, licensing models that are in there actually support the feature set itself, and it's on.
So what happens if you have that policy that you're trying to apply to a variety of devices, some of which can do it and some of which can't? Does it fail for all of them, or will it apply only to those that can support it? Yeah,
so we will only provision 2 nodes that support it. I will say that I took that slide out, but right now it's supported on the 390, 9300 in management mode, and then all of our wave 2 and up access points. So if you have MR42s, 33s, et cetera, any of those do support inline tagging and adaptive policy.
But if you take one of those MRs and you've got a MS250 or something, if that doesn't support the tagging, even if I tag at the endpoint, it gets dropped when it hits the switch.
Yeah. So what you would do is under the, and actually, let me just show you. Oh man, this is gonna kill me. Why can't I zoom back out? Let's see here. Oh, look at all those monitor modes and ports. So if I was to scroll forever and find a port here, okay. If we look at let's say an access point connected to a switch where I do actually want to tag traffic, we have a couple settings. So we have this, if it's a trunk port, and we did this deliberately, only allowing tag propagation on trunks. Because if you needed to have a single VLAN, you can obviously restrict the VLANs, but this means that someone doesn't accidentally start propagating tags to things on access ports, because usually those are client devices. So we have this pure SGT capable function. So if you enable that, and then you select the trusted tag, which in this case is 2, which is the infrastructure tag, or TrustSec devices tag in ICE, and click update, that actually then propagates tags out. So the connected device has to understand them. If they don't, you can just turn this off. And you could either attach tags, statically attach tags ingress into that port, or if you don't have a tag defined and you have IP to SGT maps, you can map those. So if you needed to have devices behind the MS250, for instance, have a tag attached at some point, we can do so as it ingresses into a 390, for instance. Couple things for the future, right? We are going to be leveraging this as our kind of our foundation for zero trust within the network, within the organization. And the reason behind that is the fact that we're not only able to provide incredibly granular policy between endpoints, but also that identity context. Today, we don't have support in the MX. It is coming in MX18. And the idea is to carry it over VPN, as well as be able to apply policy based on that tag.
Will that apply to the VMX as well?
Yes, absolutely. In this case, may come later, but yeah, the intention is to have that, especially or in VPN concentrator mode as well. But the idea here is to be honest, it's super cool. First time I set up a VPN that could carry tags over it, I was doing a lab with a coworker of mine, and watching the traffic come in tagged and be able to apply policy and see it working just across 2 very disparate networks. Very exciting. Maybe that's just me. I'm kind of a nerd, but the other piece here is, and I mentioned this a little bit earlier, but being able to hey, at the MX, instead of having to match based on subnets, don't have to do that. What if you could just attach a adaptive policy group or groups and then have a policy outcome? And so I actually think that's honestly one of the most exciting aspects, because I've built firewall policies. I've built Active Directory integrations into them, and it's never fun, and it's sometimes slow and doesn't always update. In this case, we don't have to worry about connecting to AD. We can have the endpoints assign those tags, maybe through Radius, for instance, is our kind of our integration point, and then be able to have really granular policies at that firewall and rubber stamp that policy. So when you build, multiple networks of policies, usually you have to match based on source subnet, and then that means everything changes. Every single site has a unique policy, even if it's the same goal, right? Because we have to specify that source address. In this case, we can actually make something very granular and do so in a manner that you can replicate effectively to each site without having to worry about adjusting for the subnet differences.
Can you match on things outside of the the port or the IP? So if you look at what ICE can do with profiling, do you have the ability to get more information? You mentioned, AD. Can you base it on AD groups? Can you base it on certificates? Or
oh yeah. So we interoperate with ICE, and so I would suggest actually using ICE to do the profiling, posture assessment, all that. Okay. Because that means we can actually grab so much information to make an outcome decision, right?
Okay.
Instead of
Meraki kind of on its own doesn't necessarily, but yeah, the integration then ICE. Let ICE do all the identity stuff, and then Meraki handles the policy. Okay.
And the nice thing on the 390 and the 9300 in management mode is we have device sensor enabled when you turn on accounting. So we will send lots of data, and we don't stifle it at all. And then the other aspect of this is being able to take traffic, whether it's from a VPN client, teleworker, and being able to still apply the same level of depth of policy. This is kind of how we kind of get into that zero trust framework itself. Now, this is going to answer your question.
Yes.
So as I mentioned, we built this so that we can interoperate with other Cisco SGT-based security domains. That could be, honestly, it could be SD access, where we have traffic ingressing, egressing at like a border node, or even at the edge. Technically, you can get tags propagating into the fabric by port configuration, or even like a firepower appliance or some Nexus switches. Being able to propagate those tags back and forth is great, and we really only have to do a couple things, and it's that tag propagation based on the that egress interface's connectivity. But the policy part is the difficult part, because if you have to change configurations, you change it in two places, or in 3.2. I'm excited. I think I might be the first person to talk about this live, but ICE 3.2. Patch 1, I think, is going to have a native syncing functionality. So you'll go into ICE, define your policies, define your tags. And if you put your API key in, ICE will be able to make sure that those policies are synced in, provisioned directly from ICE. So I'm excited about that, because a lot of large organizations, they have a security team that manages ICE, and network people don't. And they're not supposed to touch anything. So allowing those security folks to continue to manage the security policy itself in the same place means that a lot less work. We do actually have a container that was written by a coworker of mine that takes the ERS API and the Meraki dashboard API and then syncs from ICE to dashboard. But this brings it in as native. So instead of having to run like a Docker container somewhere, you just install ICE and sync it. So does that help?
Yes.
All right.
Just a quick question on that. Presumably the flow of configuration then is ICE to Meraki, not Meraki back towards ICE.
Correct.
You have a drawn,
I should have done a better job.
but I just wanted to be,
Yes.
okay. I'm presuming that you don't want to allow people to log into the Meraki dashboard and force
No, not at all.
policy back into ICE.
So I can change that there, arrow.
No, I
right
just
after
want to make
this.
sure I understood.
The one other piece here that I really like is if we start sending flow telemetry to secure network analytics, we can start actually visualizing traffic flows. We can see policy hits or policy effectively events where instead of building a policy by licking your finger and putting your finger in the air, you can actually look at the traffic that's happening and maybe monitor and then build your policy with actual data to back it up. Because in the end, my goal, and I think our goal in general, is to ensure that we can have these multi-domain hybrid environments, have this functionality and give customers the ability to attach a client wherever it is in the network and get that same outcome, that same experience, that same policy and control.
You mentioned the Nexus boxes and then integration with Nexus. What about ACI mode?
Yeah, so you still have to do the phase 1 integration where you use like a router to sync the EPG to SGTs.
Okay.
So when you were talking about being able to sync from ICE in, and then earlier you talked about the kind of the scale limitations between the two. What happens if you get more stuff in ICE? Will it try and import and hit a threshold?
So yeah, there's some limitations put in so that you can have up to 60 that are synced. I need to see it again, but I believe they added in the ability to select which ones you actually do sync up to dashboard.